Hello, everyone. You know the drill here. We're going to do a Leetcode question. We're going to look at the daily questions and see if we can answer them. So, let's see. Shortest path to a binary matrix. Okay, so 0 is an open space, 1 is a wall, and guess you can go diagonally as well. So, but basically, you can only move towards the zeros. And you want to find the shortest path from here to here. And from the top left corner, from the bottom right to the right bottom corner, the shortest path here is 1, 2, 3, plus the first one, I guess, so it's 4. And there's also another path here. It's like 1, 2, 3, 4, 5, but it's not the shortest path. So this is standard BFS question. Shortest path is normally a BFS question. So if I were to be given this in an interview, I would do this. So let's see. Does it determine? Well, let's get something working first, and then we'll figure out the edge cases. So Q equals, I think I could do a dq here, dq, and I'm just gonna store the top left corner with a distance of 1, and then while there's still items in the queue, there it is. Oh, it's not Vim. I want Vim. Well, there's still items in the queue. What I want to do is I want to get the next one, which is yx. This is, by the way, yx distance. So yx distance equals the next item in the queue. And then now if the next item in the queue is the bottom right corner, then I'm done. If x or y is equal to, let's probably do n equals length of grid, m is equal length of grid 0. If that is equal to the bottom left corner, and that is equal to, basically the bottom left corner, this is the code for that. Then I return the distance. Otherwise, I need to do more work. I need to find it, right? So for the directions, I'm going to declare directions here. Basically, they're just vectors of directions. So 0, 1, corner is 1, 1. Bottom is 0, no. Yeah, so 1, 0. Corner to the left is, so that's going to be 1 down, -1 left. So 1, -1. This is -1. This is -1. This is -1, -1. and last one is -1, 0. So there should be 8 directions. So 1, 2, 3, 4, 5, 6, 7. So I'm missing one. So 0, 1, 1, 1, 1, 0, 1, -1, 0, -1, -1, 1, 0. Oh, I need a -1, +1. -1, +1. Perfect. So let's do that. And then what we're going to do is we're going to iterate through every single direction vector in the what we're going to do is want to make sure it's within the bounds of the matrix first. So great thing about using Python 3 is that you could do something like 0 equals say x or y plus actually the direction in dx not dx, dy dx in dir, because the first one is the y. So the change in y and the change in x and that item is 0. Then the next thing I want to do is I want to make sure that I mark that as visited, which is I'm just going to overwrite the grid. I don't think I need the grid. I mean, if this is a real software, I would be very careful about overwriting the grid, but we just want to solve the question here, so I'm going to overwrite the grid into some number, so then I know that that's already visited. And then in the queue, I want to append the neighbor, so this is y plus dy, x plus dx, and then the distance plus 1. Right? And then that should find a corner if there is a corner. If there isn't a corner, then I return -1. I just realized too that some of the edge cases is like if there's no start at all, there's nothing in this question that said anything that well, if it's possible to not have a path, then you want to make sure that you also say, okay, well, there's no path if there's no start, there's no path if there's no end. So there's no start or end. So what I want to do here is if there is no start, which means that the grid 0, 0 is equal to 1, then I return -1. Same thing if there is no end, n minus 1 is equal to 1, that I return a -1. Okay, so now there is an end. Yeah, basically. And then the rest would be handled by this case where, well, I can't find it, right? So let's see. So far so good. Let's, for sanity's check, let's look at this one. I'm pretty confident with my answer. BFS is a pretty straightforward algorithm, so it shouldn't be too bad. It's more of a medium problem, I think. It's a little bit harder to figure out what the distances are. There we go. Let's see. 77. So makes sense. BFS is linear time. so it's quite fast. So it's 77% of all the submissions, and I don't know what these other guys are doing, but they're doing it pretty. Oh no, actually, right here, they're doing more optimizations that I could think of. I can't think of right now. So yeah, well, next time, and yeah, hopefully that gives you an insight on how like a software engineer would solve a questions like this on an interview. So